Welcome. My name is Jeremy, and today I'm going to talk about the project that we have with my friends, the passive temperature regulation jacket. This project started as a final project that I worked on with, my colleagues. Our original goal was to redesign the jacket and find a better way to make it more comfortable in different temperature. Uh, as I continue thinking about the project, I wanted to modify the original idea. Uh, so the project is not going to be ready like that we made at school. I modified the design using the three main material, hydrogel, paraffin wax, and graphene. Each material would have different purpose, and together they could help jacket respond naturally to change to changing temperature. One of the main problem I wanted to solve is that a normal jacket is designed mostly to keep a person warm. This is useful when the weather is cold, but it can become uncomfortable when the temperature is increases or when a person is physically active. Instead of making a jacket that only provide isolation, I wanted to create one that could help manage both heat and cooling. My idea is based on a passive temperature regulation, meaning that the jacket would not need a battery to do most of its work. The first material I would use is paraffin wax, especially a phase change material. Paraffin can store and release the heat depending on the temperature. When the jacket becomes warm, the paraffin begins to melt and absorb some of the surrounding heat. When the temperature becomes cooler, the paraffin started to solidify and release previously stored. I would place the paraffin inside small sealed pockets throughout the jacket, especially around the chest, back, and shoulder. In this way, the paraffin would act mostly like a thermal storage system inside of the jacket. The second material would be hydrogel, which could be used mainly for cooling. One question I have, One question I had while developing this idea was where the hydrogel would get the water needed for evaporation. The answer is that the hydrogel would need to be preloaded with water before the jacket is worn. I could design the jacket with the removable hydrogel panels that can be soaked in the water and then placed back in the jacket. The hydrogel would absorb and hold the water, allowing it to slowly evaporate over time. Sorry. As the water evaporates, it takes heat away from the surrounding area. This creates a cooling effect. The jacket could have ventilation opening around the underarms, back, and neck to allow her to move through the jacket and help the water evaporate. The wearer, the wearer, the wearer could also refill the hydrogel panel with water when they become dry. This makes the cooling system simple and does not require electricity. Another possible source of moisture would be a personal sweat. A moisture wicking inner fabric could move some of the sweat away from the skin toward the hydrogel area. This is a good thing, I think, to avoid sweating on the jacket and using that recycling that to provide a cooling effect. However, I would not depend completely on sweat because people sweat at different rates. For my prototype, I think using water that is added to the hydrogel because wearing the jacket would be more reliable and easier to control. The third material is graphene. Originally, I considered graphene as a possible possible material for electrical heating, but because I decided not to use battery, I would use it differently. Graphene is an excellent conductor of heat, so it could be used as a thermal management layer to help split heat more eventually throughout the jacket. Instead of generating heat, the graphene could help move heat away from the area that becomes too warm and distributes it across the larger area. This could work together with the paraffin and hydrogel layers. The jacket would be designed with several layers. The outside could use a lighter and breathable fabric that provides some protection from wind and rain. Und- Underneath, that would place the graphene thermal layer. The paraffin PCM pockets could be placed in storage areas such as the chest and back. The hydrogel panel would be closer to the inside of the jacket but separated from the skin by a comfortable moisture wicking fabric. Ventilation opening would also be included to help air move throughout the jacket. The jacket would work differently depending on the environment. When the wear is cold, the paraffin could release some of its stored heat as they change back to the solid state. The jacket Isolation would also help keep that heat close to the body. When the wear become warm, the paraffin could absorb some of the excess heat, while the hydrogel could provide additional cooling to the evaporation. The graphene layer could help distribute heat and prevent certain area of the jacket from becoming too hot. One advantage of this design is that it doesn't not depend it does not depend on battery. This could make the jacket leather more comfortable and easier to maintain. It would also eliminate the need to charge the, the jacket every day. However, there are there are there are limitations. The hydrogel would need to be rehydrated when it loses its water, and evaporation cooling would not work as well in very humid environment. The paraffin can also only store a certain amount of heat before it's reached its capacity. Graphene would help with heat distribution, but it would not produce heat by itself. Because of this limitation, I would not describe my jacket as a product that can perfectly control body temperature in every moment. Instead, I see it as a passive temperature regulation jacket that can help reduce temperature change and make the wearer more comfortable. The next step would be to build a small prototype and test each material separately. I could compare the temperature of a material jacket with the temperature of the redesigned jacket and see how much different the material make.